What is going on, guys? Welcome to another video in my tutorial series on digital logic. Now today we're going to be talking about encoders, and what an encoder is basically a device that takes 2 to the n inputs and spits out a n number of outputs. Alright, now what do I mean by that? So suppose we have well, first of all, suppose n is equal to the value of 1, for instance. So that would mean we have 2 to the 1 input, so that would be 2. And since n is 1, we would have 1 input. So this is what an encoder is, as far as how many inputs and outputs it's going to have. Now let's take a look at another example here. Okay, so first of all, it's 2n, and we're going to have an n number of outputs. Alright, so if we had 2 for our n value, so that would give us 4 inputs and 2 outputs. Alright, now what an encoder is typically used for is simply this. We are going to basically encode or change the value of a binary number, for instance right here, to its a decimal number right here, that's what I meant, into its binary representation. So this, for instance, if this was the least significant bit, alright, if 0 was selected, and at any point in time only one of the 4 inputs or one of any number of inputs can be selected. So if 0 was selected, I would want the binary representation of this decimal number 0, which would give us 0, 0. Now if 2 was selected, it should give us the value of 1, 0, which is the binary representation of 2. Okay, because this is the least significant bit. Alright, now why don't we go ahead and draw a truth table for this? But before that, why don't we do this? We have our 4 inputs here, and I'm gonna label this D0, D1, D2, and D3. Okay? And same thing, we're going to have our 2 outputs. I'm going to call it Y0, Y1. Alright, so now let's go ahead and draw the little table we have here. D0, D1, D2, D3. Y0. Oh, you know what? Let me switch the order of these. Y1, Y0. Now, the order of that does not matter, but in a little bit you'll see why it's a little better for readability. So if D0 is set, aka the very first input, so remember at any point in time only one of these values can be set. Alright, so all the others would be set to 0. Alright, we want our output to be 0, which is in binary format it would look like this: 0, 0, and this being the least significant bit. Alright, I'm gonna write it down there. Okay. And now we're on to D1, and D1 is gonna be the decimal representation of 1. And what is 1 going to look like in binary? Well, it's gonna look like this: 0, 1. Alright, now hopefully you guys are understanding this now. If for D2 is the value, it's gonna have the binary value of 2, the decimal value of 2, and that's gonna look like this. Right, now lastly we're gonna have D3, and this is the binary representation for 3. Now, I'm going to go ahead and draw the actual logic as far as gates go as to how this is implemented. Alright, so let me go ahead and do that. If we had the value 0, 1, 2, 3. Well, you know what? Since I already labeled these D0, we have D0, D1, D2, D3. Alright? Now, oops, sorry about that. Now, D0 is going to be connected to nothing, because if you look at the truth diagram here, its output, you know, is going, whenever D0 is set, its output is going to be 0, so we can just leave it as nothing. Now for D1, this is actually going to be connected to an OR gate right here, and if you look at, there's actually going to be another OR gate, and D2 is going to be connected to Y1, so we're going to label this Y0, Y1, and D2 is going to be connected to Y1. And we look at D3. D3, when D3 is set, it's going to be connected to Y1 and Y0. Alright? Okay. And this is what we call a 4-to-2 encoder. Alright, I hope you guys enjoyed this series, and I'm really sorry about all the little mistakes I've made and the keyboard falling over. I hope you guys enjoyed this video regardless, and I hope to see you guys in the next video.